we out here with some new math. We got factorials, combinations, permutations. So watch out, Mr. P on the track. Let's get it.
I'll just, thanks for the intro. I'm going to correct one word though.
All right.
I like how you said it though. Permutations.
I was just playing
Spell
around.
it right.
Spell it right.
That's an N. Sir.
They just become an R. It's transformed. So this is 431. Factorials, combinations, permutations. This is what we're going to do for the next 2 weeks here. So today we're getting in kind of the foundations of this. Next week we're going to do some more problem solving with it. But just like the last 2 weeks, this isn't something that you can just kind of get to the quiz and hope that you know how to do it. You got to learn the different symbols. You got to know what the exclamation mark means. In this case, it's talking about factorials. Nothing up here is really tricky. It's just new. All right. Nothing up here is incredibly tricky math-wise, and we can use technology for it. Okay. So don't sweat it if you're looking at this and this looks totally intimidating. It really is, and I just have to teach you what these symbols mean. That's all. Okay. So to start, factorials, product. What are we talking about with a product? What kind of answer are we looking at? So like the answer to a addition problem is the sum, right? So how about a product is what? Multiplication. So maybe if you didn't know that, we're talking about multiplication. Integers are just positive numbers. Okay, these are just positive numbers. All right. And what we do with the factorial, when you see this symbol, it just says multiply all the integers that precede it. So if I have factorial of 4, I multiply 4 times 3 times 2 times 1. Okay. That's what that symbol means. What you can use with the calculator actually is you push 4, and then sometimes it has just the factorial, or it'll have in factorial, and that goes right to what it is. So is that really tricky? 4 times 3 times 2 times 1? Maybe if you had like factorial, if this was like 23 factorial, what would that be? 23 times what? 22 times 21. If you had to do that by hand, it'd be huge. That'd be tricky. But you can use the calculators I have for this. I don't mind if you use technology for this, or you can use Desmos. It has a combination, or sorry, the factorial on that too. Okay, so let's look at this. Let's try one of these. Just go ahead, since we already copied down to the blue. We'll just do these 2 problems that are in blue. So somebody help me out. Or actually, do it on your own, right underneath on your paper. I want you to just write 3 factorial, and what does that equal? Go ahead and do that out. And these are ones you could do without a calculator. So at least have a couple good sample problems down. Yeah? Oh, down here? I'm going to give you a moment after we do the first section to copy down the second section. Yeah, we're just basically, we copied to here, and now we're going to do the blue problems up here. All right. Who has confused? Okay, Alejandro, can you clarify everything?
6.
Okay, how'd you get that? So factorial of 3, we take 3, we multiply it by 2, we multiply it by 1. Okay, so the factorial is just 3 times 2, that's 6, times 1, 6. That's all it is. That's all it is. That's all it is. So if I have factorial of 5, go ahead and do that on your own, and then after you're done, check with your neighbor, see what they think too. See if they think the same thing. Factorial of 5. That's 4. 6. That's 2. Got this? Easy. All right. Yep. Okay, someone in the back want to impress the class, show us how to do this? Yeah.
I got 120.
120. Who got 120? Raise your hand if you got 120. All right, how do we get that? 5 times? 20 times 3 is 60, times 2 is 120, times 1 is 120. Okay? So a factorial is just multiplying that number, whatever it is, times all the numbers that precede it. Okay, it's kind of new. It's kind of weird, right? It's kind of like a right. So you know, if it was 10, then I would have to go in here and do 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or I can get a calculator and go 10 plus this button, and you get your answer. Let me see if I can do this in my head. 90? No, I don't want to do it. It started and it's Monday, it's still early. All right, so 10 factorial. Whoa, I'm glad I didn't do it. Do you guys get it? Big old number. 3,628,800.
Funny. I was gonna say that, but
I mean, you didn't want to show off.
I didn't want to. Yeah.
That's good. Be humble. All right. Thumbs up, sideways, or down for factorials. How do you feel? Yeah, we can do these, right? Okay, good.
Until we get to the combination.
Can someone double check on their iPhone if they have the factorial button when you turn
It's
side?
an X.
It's an X. Okay, so on the iPhone it's X exclamation mark. You just got to look for the button. And if you don't know, go ahead and do a number that's easy. Do 3, right? 3 factorial. See if you got the combination right. All right, I'm going to go ahead and pause it. Does anybody want to do a shout out / pause outro?
I love you, Mom.
I love you, Mom. Okay, good. And we're back. All right, we're back, and we are going to talk about combinations. Okay? Good note? All right. So, combinations. It's just a set of objects. It could be food on a menu. It could be numbers. It could be letters, just like we had over here in the warm-up. The combination, though, the order doesn't matter. Order doesn't matter, and you can repeat. So which one up here would you say, that's definitely a combination? Which one's a combination? It could be a combination, or what we're going to learn next, a permutation.
They're all.
Wait, what?
They're everything except RBK 2
Yeah.
2 4.
Very good.
Wait,
So
would it be?
R.
Right, so the difference between these two? These would count as combinations of those same kind of numbers, right? But when we learn about permutations, the only difference is you can't have any repeats. Okay, so these are still like, think of it as just a concept so far. But when you have a combination, it's just any kind of objects. Order doesn't matter. Doesn't matter what the order is. So that would be saying that 1, 2, 3 is different than 3, 2, 1. Okay. It's the same objects, but they're just in different order. It doesn't matter. This is combinations of those numbers. The way I remember this is, you can think of, here's the notation, big old C here, and on the left and right are in and R. Those are the two numbers we're looking for that we're going to input here. The way I look at it is in is the number of objects on the menu. So think if you're going to order some food, in is the number of objects you choose from. So who's been to the Cheesecake Factory? Anybody? Has anybody seen the novel they call a menu?
Yeah.
The novel that has like 45 pages. There's like 200 items in there.
That's a menu? You can have
Their
200
menu.
different cheesecakes?
It's not just cheesecake.
Not just cheesecake, like pasta.
Spaghetti.
They've got like
Food.
every type of food, but they've got like 7 or 8 options for each.
Exactly.
That's ridiculous.
So say,
Up to 10 for some of them.
for sure. So say if we're at the Cheesecake Factory, right? The number of objects on the menu will say it's 200 objects, 200 items. The requested items are, say if I'm going to only order 3 things, okay? It can be a combination of all those 200 things. So the number on the left is in, that's the number of objects on the menu. R is the requested items. That's just the way we can kind of look at it that way. Okay. So let's see if we can do one of these practice problems. I think we can. Cheesecake. All right, so we look real close. Here is our formula. We're going to have this available to you on the quiz. Okay. So what should I put on the top as far as a factorial of n? Look over here. Right, Anton?
Yeah.
This right here is our n.
Number of objects.
Now it goes on top. Number of objects, so we're going to go 3 factorial. And then what's going to go on the bottom?
Your requested items and the, and subtract the requested items.
Good. So we'll go 3 minus 2 factorial, and then what's left? R factorial. What should I put here?
2.
Yeah. Right? We're good? I don't know. All right, what's factorial 3? We did this already. 1 already?
3 times 2
times 1? 6. What's 3 minus 2? 1. What's factorial of 1? 1. What is the factorial of 2? 2 times 1, right?
Yeah.
2. So now we have 3 divided by, this is going to be just 2 on the bottom, so what do we get? Sorry, 6. I give you the answer. Hey, what? 6 divided by 2 is?
3.
3. Done. Okay. Okay. So remember today, right now, we're just working on the concept and how to approach these problems with the formulas. The rest of the time, we're going to kind of do a little more problem solving. But, you know, we'll start slow. All right. Next, right here, down to the squiggly line, I'll give you all maybe 2 minutes for that. Any video pausing, outro shout-outs?
Not right now, at the moment.
Not right now. Okay. We'll just pause. Boom. All right, we're back. All right, permutations. Who right off the bat just doesn't like that word? Anybody?
Yeah.
It sounds like
you have
fermentation,
a person.
so it sounds kind of
Sounds
gross.
like you want
It's confrontational, isn't it? And this is one thing I want to pop down here. The hint, permutation sounds really complicated. It sounds complicated. It has more rules. All right, so you ever met somebody that is just kind of uptight about doing anything? They have all these rules to life, you know? And their life's really complicated because they're always negotiating all these things they think they have to be and all that. So permutations does sound more complicated because it is, and it has more rules. That's the main thing here. Order matters. Order matters. What order those objects are in, and there's no repeats allowed. So which one of these from the warm-up would you say is a permutation?
2, 4. This is an order from
2, 3, 4?
Yeah.
Okay. Any others? RBK?
Yeah.
How about these two? Why aren't these permutations?
Because they're
same
common.
thing, different.
Same thing in different order. That's a good way to look at it. Yeah, commutative property. So there's a 2 and a 2. We know repeats. That's not right. And comparing these two, they're not in the same order. So we know that it doesn't fit to permutations here. All right. So we have this. The same thing applies. Permutation, capital P. And then we have number of objects on the menu and requested items. That's the way I like to think of it. It's almost exact same thing. What's missing here? What's different? Either the R factorial on bottom. We don't have it over here. Okay. So let's see if we can do this one. I'm going to go ahead and give you a moment just to set this fraction up. Go ahead and do that. Permutation of 5, 5, 4. Also, sometimes on your calculator you'll have to do this. You'll put the permutation function. You do the permutation function, then you put it in there as a pair of numbers, 5, 4. So if you have your calculator, give it a try with your calculator too. Make sure that is possible. iPhone has it. I'm sure Android has it. Let's see.
Probably not. It's Android.
It's
Android.
Turn. Oh, it does have it. I don't mind that song. You can outro that if you want.
It ends on a good vibe.
Who doesn't sing with that when it comes on? Come on. Very singable. Okay, somebody help me out. What goes on top? What goes on top? TK, what goes on top? A 5. Yes. Either look 2. Okay. 5. How about on the bottom? What two numbers should I put in here?
He scared me.
Okay. Spooky Jordan, what goes on the bottom?
5 minus 4. With the exclamation point.
What's 5 factorial? We already did this.
120.
What is 5 minus 4?
1.
Factorial of 1?
1.
So we get
120. Right. I got it right.
right. Now let me tell you, let me just kind of bring it all together. What this is saying right here is that given there's 5 items on the menu, and I'm going to request 4 items, there's 120 different permutations you can have of those items. Okay? Ways that you can split it up and make different permutations for it. Combinations, there are only 3 ways that we can do this for combinations. When we have 3 items and you're given 2. So 4, that would be, actually let me double check this. How do we do this? 4, 3, 1, factorial of 5. Yes, factorial of 5, 4, 3, 120. Okay, we're good. Question?
So, what does that mean again?
So let's look at combinations right here. So the order doesn't matter, and you can repeat. So I can always do 1, 2, 3, or I can do 3, 2, 1. Right? So if we have a certain number of objects and we're going to request a certain, like 120 different menu items at Cheesecake Factory, and I'm going to select 3 things, then the number of things I could do, like spaghetti, cheesecake, and a milkshake, right? Or I can do, you know, pasta, chicken pasta,
Mr. P, you're making me hungry.
salad, just kill it.
Don't keep going.
Something inedible, garnish, right? So we're talking about how many sets of objects, like we did in the warm-up, how many we can have with combination versus permutation. And you know what? I'd actually like to keep it and stop it right there, because I think the rest of the week we're going to get into tangible examples. Okay, so for now today, I just want you to practice the methods. All right, and we'll go ahead and stop it there. Remember, 123rd gets Oreos. Oreo packet. I think I'm around 100. Let's see. Let's see. It's exciting. Here it comes. I need to sign in. No. 96. That's right. That's right. Okay, cool. Yep. Yes, you may. All right. Thanks for joining us.